Welcome to solverfy.
Okay, we have the following initial value problem. We're told that y prime, which is equivalent to dy over dx, derivative of y with respect to x, is equal to 3y, and we're given the initial value that when x is 0, y, the function y, is equal to 5.7. So how do we solve this? Well, I like to take the right-hand side of this, right? The dy over dx, which we are told is equal to 3y. And then we do a little bit of algebra magic, right? We multiply both sides by dx. Okay, so what we end up with is that dy is equal to 3y dx. And so from here, we look like we have, well, maybe like an infinitesimal change in y times 3 times y times an infinitesimal change in x. But we don't want to know about infinitesimal values of y or x. We'd like to know about y or x. So what do you do to infinitesimals to determine, a more reasonable, useful value or function from them? You integrate them, right? So we're going to integrate the left-hand side and the right-hand side. And so what you may notice now is that we basically have the integral of 1, right? A multiple of 1 can be put in anywhere with respect to y is equal to, now we've got something we can factor out here, 3y, right, as a multiplicative factor of the integral of 1 dx. Right, we're pulling it out as a multiplicative constant. Okay, so we can now finish this integral. What's 1 integrated with respect to y? Well, it's just y, right? And that's equal to 3y times, what's 1 integrated with respect to x? That's just x. And don't forget that whenever you do an indefinite integral like this, you need to add a constant. Technically, we would add a constant to both sides. So we can say y equals c1 plus c2, right? But that ultimately, whenever you have arbitrary constants like this, you can move them all to one side of the equation and just refer to them as c, which we can do in this step by subtracting c1 from both sides. To get that we have now y equals 3yx, and we're going to just say plus c without any numbering. This is just going to be our c from here on out. And if we want off to the side, we can see c equals c1 plus c2. Sorry, c2 minus c1, but it won't make a difference. Basically, you're always allowed to just combine arbitrary constants and not really worry about it, but I didn't want to skip any steps, so I included that. Okay, so now we've got y is equal to 3 times y times x plus our arbitrary constant c. Okay, and it's at this point that if we so desire, we could find our constant. Right, so to do this, we would just take our information that y of 0 equals 5.7. Remember, what this means is that when x equals 0, that implies that y equals 5.7. Okay, so we can plug in these values. Well, we could say instead of y, we get 5.7. Okay, 3 stays the same, but this y we have here turns into 5.7. We know our x has to turn into 0 because that's what we're talking about, what happens when x is 0. And then we get plus c. Okay, well, 5.7 is just 5.7. That's fine. But here we have 3 times 5.7 times 0. Anything times 0 is 0. So, in fact, on the right-hand side here, we're just going to get c. Just like that, by using our initial value, we've determined the value of c. c is equal to 5.7. Okay. So now, at this point, we have more information about our equation. We can put it back in the form from 2 steps ago. Put that information into here. And we can say y is equal to 3yx plus now 5.7. Okay. And most typically, we will find, sorry, this was our general solution. I forgot to mention that here. right? When it says to find it in the general and particular solution, this is the general solution. Okay. But then once we include the information about our initial value, that's when we get our particular solution, which means what value does C take on given the data we were given. Okay, so that's what we're finishing up here, is finding our particular solution. And typically, I mean, we could say we're done here. This could be considered our particular solution, but it's kind of standard to get your y on one side of the equation. So that's going to be our next sort of step. We'll subtract negative 3yx from both sides to get y minus 3yx equals 5.7. And then we'll factor out a y to get 1 plus, sorry, not plus, 1 minus 3x equal to 5.7. And we will divide both sides by 1 minus 3x to get 1 equals 5.7 over 1 minus 3x as our particular solution in y equals a function of x form. This is particular. If we were to do the same with our general solution that we found above and get that in terms of y on one side of the equation, we'd follow the exact same steps. We would get y equals, but instead of 5.7 here, we'd get c over 1 minus 3x. And a good thing to do when you do these types of problems is check, does my initial value that I was given make sense with the data or with my final equation? That is, if I take y equals 5.7 over 1 minus 3x and I plug in 0 for x and 5.7 for y, is what I get true. And yeah, if you plug in 5.7 for y, you get 5.7 equals 5.7 over 1 minus 0. 1 minus 0 is 1, and anything over 1 is just itself. You get 5.7 equals 5.7. That is true. So that's just a little check you can do at the end.